Hello all, welcome back. In this problem solving session, we are going to see the topic related to linear support vector machine. So in the given dataset we have four positively labeled datasets and four negatively labeled datasets. The positively labeled datasets namely 3 1, 3 minus 1, 6 1 and 6 minus 1, and negatively labeled data points are 1 0, 0 1, 0 minus 1, minus 1, 0. And in 2D view, the positively labeled data and the negatively labeled data will be look like this. In the blue dots indicates the negatively labeled data points, and this orange dots indicates positively labeled data points. For this data points, we need to have a hyperplane. You need to draw a decision boundary. So if you look at this, the decision boundary will become around 2, right? And that a line parallel to y-axis will be drawn by crossing the point x equal to 2. That we need to prove. Fine. When we look at this 2D view, we could able to clearly say what are the support vectors. The support vectors are the vectors that lies near to the hyperplane. So hyperplane will be coming over here by physical view. So we can say the support vectors are the points 1, 0 and the points that comes over here 3 1 and 3 minus 1. These are the support vectors. As I said earlier, the support vectors are s1, s2 and s3, and the respective values are 1 0, for s2 is 3 1 and s3 is 3 minus 1. So next step we are going to add the bias 1 to each vectors, namely s1 cap which is equal to 1 0 1 and s2 which is equal to 3 1. So it will become like s2 cap which is equal to 3 1 1, s3 which is equal to 3 minus 1. So s3 cap which is equal to 3 minus 1 1. So we have three variables. So we need to calculate the three weight vectors, right? Namely alpha 1, alpha 2 and alpha 3. So here the equation comes alpha 1 into s1 cap into s1 cap plus s2 alpha 2 into s2 cap into s1 cap plus alpha 3 into s3 cap into s1 cap, which is equal to minus 1. How this minus 1 comes? This minus 1 indicates you have only one value from the negative label data points, that is s1, and this plus 1 and plus 2 indicates s2 and s3. So it comes under positive label data point. So we have given plus 1, right? So here directly I am substituting the value of s1 cap, s2 cap and s3 cap. So s1 cap value is 101 and s2 cap value is 311 and s3 cap value is 3 minus 1 1 respectively. While we do the dot conversion among these two vectors, you will get alpha 1 into 1 plus 0 plus 1 plus alpha 2 into 3 plus 0 plus 1 plus alpha 3 into 3 plus 0 plus 1, which is equal to minus 1. Same way for remaining two equations. If you simplify this, you will get 2 alpha 1 plus 4 alpha 2 plus 4 alpha 3, which is equal to minus 1, 4 alpha 1 plus 11 alpha 2 plus 9 alpha 3, which is equal to plus 1, 4 alpha 1 plus 9 alpha 2 plus 11 alpha 3, which is equal to plus 1. And by simplifying this equation, we will get three values of alpha 1, alpha 2 and alpha 3 respectively. The values are minus 3.1 for alpha 1, 0.75 for alpha 2 and 0.75 for alpha 3 respectively. And once we get these three variables, namely alpha 1, alpha 2, alpha 3, we need to calculate the weight vectors. The weight vectors are sum of I, that I varies from I which is equal to 1 to n. In this case the value of variables is 3. So alpha 1 into si cap s1 cap plus alpha 2 into s2 cap plus alpha 3 into s3 cap you will get. So here alpha 1 which is nothing but minus 3.5 and s1 value, s1 cap value is 101 plus alpha 2 is 0.75 and s2 cap is 311 plus alpha 3 is 0.75 and s3 cap is 3 minus 1 1. If you simplify this, you will get 1 0 minus 2. if you look at this above vectors augmented with a bias, the bias value is minus 2. So the hyperplane equation y which is equal to wx plus b within w which is equal to 1 0. The weight vectors are 1 0 and the bias b which is equal to minus 2. So by SVM decision boundary is given as w1 x1 plus w2 x2 plus b which is equal to 0. In this case the weight vectors w1 w2 are 1 and 0. Just substitute in this equation and b is minus nothing but minus 2. So if you simplify this, you will get x1 which is equal to 2 and x2 which is equal to 0. So you will get a point x2 comma 0, that is a line parallel to y axis you need to draw. So here the weight vector is 1 comma 0, right? So at 1 comma 0 and bias b equal to 2, that means this hyperplane moves away from the origin with a distance of 2, right? Suppose instead of 1 0 if you are getting 0 1, in that case you need to, with bias b equal to 2, in that case we need to draw a line parallel to x axis, right, by crossing the point at 2 in y. Here suppose if you are getting 1 1, by that time you need to draw a 45-degree line that crossing x and y axis, and we need to find the point that which point it crosses at y axis and which point it crosses x axis. But in this case there is very simple, it is 1 0, so it crosses and bias b equal to minus 2, so it crosses the hyperplane that travels at the distance away from origin at the distance of b equal to 2, right. This hyperplane separates two negative classes and positive classes respectively. Thank you. We'll meet again in another video. Thank you all.